All right, everybody, we are on to our next session here with Amit Patel from Integ. He is the managing director of Integ. Amit is a managing director at Integ, and he works directly with power generators and IPPs, as well as other utilities to strengthen outage management, GADS reporting, and compliance workflows. Amit's work is making reporting more predictable, improving data quality, reducing rework, and aligning operations, compliance, and IT teams around processes that actually hold up at scale. Amit's going to walk through how top generators are using Integ's platform for things like GADS automation, generation performance, and predictive reliability, drawing on lessons from real implementations across some of the biggest fleets in the world. And I'll add Integ is the presenting partner for the summit, and so very grateful for their partnership in making this day possible. Amit, take it away.
Great. All right. Well, thank you everyone for joining. I am going to make sure this is not really salesy or anything. I want to really talk about the problems we're seeing, right? And with renewables, especially, we're seeing where utilities are quick to adapt. We're seeing where they are not quick to adapt, and especially with everything coming down the pipeline with PRC 28, 29, 30, we're seeing that, the companies that are, not they weren't ready for the work that was there the last, 3, 4, 5 years. But with some of this other work coming up, it's going to be even more important that, folks get on the same page. So I'll kind of, rather than make this product based, I'm going to make it very general. I want to start really with automation, but as we've been working with AI, we see the potential for especially a lot of these utilities and IPPs that may be a little bit more ahead, but then the smaller folks are really far behind. They can use AI to really catch up. So I want to walk through that and how to do it safely, securely, and we don't advocate use of AI in production at all because it's not reliable. But I think folks are kind of throwing the baby out with the bathwater in that you can use AI to build solutions or software to do it much quicker, much easier. So I'll kind of walk through all of that. We only have 30 minutes, so I'll do our best, to provide as much knowledge and value as possible. I probably work across at least 50 different larger utilities, IPPs, cooperatives. We have over 100 something clients, but I touch base with at least 50 within a year. So I kind of understand what's going on with everyone, what the challenges are. Um, Really, the biggest problem is, look, if you don't have any renewables, you're kind of okay. It's not that bad. But then the folks that are just mostly fossil, I still see companies where automation, right, can really, really lead to huge benefits, but they're not doing it. But then when you have folks with renewables, and especially the folks that are adding, more and more renewables, there is no way around it. You have to automate, right? And I'll just take GADS as an example because we work with it all of the time, right? To do this properly, um, when we automate what are manual processes, we see almost up to 20% error reduction. Like literally, whole events are getting missed, things are getting miscategorized, and it's going to happen because, just to give you an example, for a large solar unit, we may be processing over 1 billion Pyre SCADA data points per plant annually, right? So we're using all of those 5-minute records and records per inverter, all of that to figure out
Wait, are
what's
you
going
sharing
on.
something?
Yes, you guys, I'm sorry, are you not seeing
No,
the
no, I
share?
think it turned off sharing when you popped into the webinar.
When I popped in, I'm sorry.
Yeah, you're not sharing right now.
Okay, I apologize. Thank you, Rashid, for pointing that out. Yeah, so the main thing is that, some of these, it's over 1 billion records, right? You can't, have a human work on this and do some of this work and expect it to be accurate. So GADS is just one example, right? And we've got, like I said, PRC 28, 29, 30, some of these things coming down the pike where it's going to be ridiculous amounts of data. So really the main thing that I want to point out is that, whoever's in charge should be really looking at how to automate and how automation is done properly. And you have reliability folks, compliance folks, and the compliance folks, and then you have IT folks. And often folks will just say, "Hey, this is coming now. I have to do it." But then the time that you're looking at it, you're often ill prepared, and it takes over a year to do some of this properly. Because one of the biggest challenges is that it's not like, some of the stuff from earlier where it's 1,000 or 100,000 records, right? These are millions to billions of records that you have to process. And it takes time to, it's not just slapping on software and doing a bunch of, dashboards. There's data engineering, data flow, what to do when, your pi tags are missing, um, or when you're getting bad data, when you have such large amounts of, data. So just want to point that out. Now, let's take a kind of quick example, right? If I'm looking at solar GADs, right? These are inverter level outages. This is just one month that I'm showing you. And these are outages after the system has pre-processed and it's saying, okay, I'm looking at bad data. I'm looking at, inverters not communicating. I'm looking at, 5 minute AC breaker, AC switch, DC, all of those types of things. How many inverters were online? What's the generation? So we're looking at all of this information. This is millions or could be 100 million rows distilled into inverter level outages. And now we have to go from this to NERC level outages, right? So the fact that folks are doing some of this manually again is still it longer term, it won't work when you have multiple um, renewable sites. And even now, the folks that we see when they go from non-automation to automation, we see that there is a significant amount of error. So just wanted to point that out. This is one example. So for here, what we do is we'll be getting 5 minute data from Pi or SCADA. Some clients will do 10 minutes, but you could be getting, 20, 30 tags per that duration. And it's going to lead to, in a month, over 100 million tags possibly that you're processing. And it's a large amount of data. So you have to make sure it's done properly. You have to talk to the engineers because each site may have, depending on the OEM, the logic may be different. But if you don't automate, then it's really hard to do some of this work. And if you actually do this work, for example, if we do this where we do this work, we're also able to detect a lot of the real-time outages at the solar site. So for example, the Renewables Operations Center would rely on manual processes before. Now, when we do this automation, we can also piggyback and you can use this same automation to figure out that, hey, do I have an outage? Or, and sometimes you have to report it internally, sometimes you have to report it to your balancing authority. And it's all one system that can do all of this, right? So you're in real time, often what we would find is the clients that where we did automation and where we didn't do automation, often, again, there were outages, small outages getting missed, and that's going to impact reliability, right? As generator owner or generator operator, in real time, you have to make sure that every outage that you have, big or small, is going to be reported because if not, the balancing authority or grid operator is going to have a hard time if enough of these are missed. So just want to point out that no matter what happens, I believe most, electric generators really, really need to get on this train and make sure that they can do automation. And really just forgetting about GADS, right? That's a great example. Also, I see, predictive maintenance. It's very, very manually based, right? It's all Excel-based workflows. Somebody in engineering has this spreadsheet, somebody in engineering has that spreadsheet, and this is, it's not done well throughout the org. As I mentioned, automated real-time outage reporting, that's another one. Again, the big problem here is when, renewables operation centers are doing this manually, we see things are often getting missed versus automation. Um, Outage planning, outage optimization, again, making sure everybody's in the loop. You're looking at, okay, what is my work that's going on? What is the what's my load? What's going to be needed based on other outages? So I can look at this fleet level as well. Generation forecasting, and this is also important because as you get renewables, forecasting becomes very important, right? So this is another one where really automation is important. Most folks are using the a forecast that they get from their provider, but these forecasts often aren't great. So near real time, you have to do work to help automate and improve that. And also automated compliance is very important. For example, I will see so many clients where, okay, an outage happens, but then they're looking at different processes for PRC4, EOP12, other processes, and everybody's looking at different sources of truth. And, if you go through this exercise of automating properly, then you're going to see that, hey, you can have one source and then you can have multiple flows. For example, if I go in here and, my outage happens, then I can send it to engineering and they can go ahead and look at the details. And then I can go in here, I can have it for EOP12, and then I can have all of this type of work automated, and simplified, right? And it's not just this then, we're now building for the PRC 28, 29, 30 or CAAT OGUR. It's, different initiatives, but it's all going to do the same thing where you're going to have data that's, billions and billions of rows just for a week. So you have to process and be able to do this type of work. Um, so one of the things we're finding when we're doing this work, right, and I'm going to kind of segue, is that uh, AI is really, really helping with a lot of this because it's once you're doing the automation, there's a whole part where you can do a lot of analysis, right? So the automation just gets you from A to B, right? So you can report your NERC data, that's great. But then how do I do my root cause analysis? What if I want to say, okay, if I didn't have these types of um, root causes, what would my metrics look like? How can I do improved forecasting? Right. So Rashed, if you want to chime in here, would be great to hear from you on AI. I know you work a lot with this.
Sure. I think one of the things which we are finding, right? So automation, we talked about it, right? We are bringing lots of data and kind of automating reports or data gathering, everything. But then the problem is automation is one thing. Then now you need to find insights of the data. How do you generate revenues, cost optimization, optimization of processes? And here we are bringing AI technologies, and some of these findings, I mean, we have a client who never even thought about that it could find some of the informations where it found it and it found out the problem statements. It found out exactly how they can optimize things and where their issues are happening. And so I would definitely encourage everybody to use AI. And Amit, if you want, I can show some of these analysis, how we're doing that. You want to do that, or you want me to do that?
Yeah. So before we start, I think I want to make sure that the approach, right, that we have is that whatever you do, our approach is that we're not running AI in production. We are using AI to build software. So I just want to be very clear. We do not support, I don't think any utilities are really supporting using it in production. We're using this to write software. And when you do this, the way and Rashid will go through this, or I'll go through this in a little bit, is that with AI, you have to have your data there connected. You have to have your knowledge. Once you have these two things, then with AI, you can work to, very quickly have solutions and deploy them. But the way this is going to work is that you bring your data in and you are going to also have your requirements. The AI is going to do coding and testing, right? The AI is going to do coding. You have to do the testing no matter what, because whatever AI creates, you have to validate that it works. And if it works, then you can deploy it and have it go. So, Rashid, why don't you just do a good example of this? And
Sure.
but before that, I'm just going to kind of show you some of what's been created. Like, we've had AI create for some cost code analysis. We've had it create different types of marginal analysis. I know this is not reliability, but the folks dollars are always important, and you can put dollars against actual reliability metrics and see that actually not having a good EAF or E4D is still costing you a lot of money, right? And then we have different types of fleet and EAF analysis, and we can have, you can look at your meter data, you can see, is it high quality, low quality? All of these things would have taken months to do, but now with AI, we were able to accurately and reliably create this, using AI. So I'll let Rashid kind of walk through a little bit.
Sure. Let me see if I can share
Um,
my screen. I think share screen. I think I'm
yeah,
sharing.
sure, Rashid. Maybe we start with something simple. Let
Like
me
cost code analysis.
Yeah, let's do so.
Sure.
Since I started with the GADS, let's assume that I'm an operator and I
Sure.
want to see cost code analysis,
Sure.
please.
So I think the first thing, your AI is connected to all your systems. So I would, over here, I'm gonna just bring my data in. I think, and here I have event data. So
So,
can,
for example, if this is John, then he would only have access to the data points that John would normally use. So there's, in all of these, you should build in data governance, right?
yeah. So let me just go to the Haiku model. Just gonna change the model here. Go here. It's the event data. And then I'm gonna bring, let's say for 2024, myth.
Yeah, so generally the way these systems work, or what that we support, is that you pick your data sources. You should be able to look at the data, because whenever you have whatever problem you're solving, you're going to need two things. You're going to have the data, and then you're going to have a problem statement. So we're just going to show you, we selected your, outage data that you're submitting for GADS, and then we said, okay, we're just looking at the 2024 timeframe. And then we're going to do cause code analysis. So we're picking what's called cause code description. The reason we pick this is that when you submit to NERC, you don't actually pick the description, you just have some sort of code. So yeah, let's go ahead and do that. You picked your data, and then now you're going to write in. So Rashid, okay, so you can also have any knowledge internally. So for example, you can write something that says, hey, I want to do cause code analysis this way. Now, this is not required, but if you want to be more precise, you can tell the system what you want and how you want to look at it. So we've kind of just added what we call knowledge, and we told it that, hey, we want some seasonal pattern identification. We want, this is what it's going to have. I want to see repeated failures. I want to see, force versus plan outages. You don't have to do that, but if you don't do this, you're going to get a more generic answer. And that knowledge is nothing more than just plain text that somebody created. So, please don't assume it's anything complicated, but each team can add their own knowledge here. And once you add that in, you're going to put in your problem statement, and that's it, what Rashid is doing. And can you just say and show me graphically as much as possible, or visually? All right.
Okay. Recommendations. Then
All right. So that's it. So the difference between using ChatGPT and this obviously is that this is linked to your data sources. It's a read only, but it will, you can look at your fleet, you can look at years, anything. It will get the data, bring it in, look at your problem statement, and it can bring in data across multiple data sources. And then if
and
you
I mean,
like
so
this,
we are not sharing any data with LLM, right? That's a big thing. So we
Correct.
don't.
So no data is shared with the AI or whatnot. This is all secure. And if you do this work and you like the output, right, you can go ahead and save it as a dashboard. You can pick which charts, which elements are going to, work for you and give you the output that you like. So this is just a quick way, and just bear with us. Like I said, there's a decent amount of data, but you can see now the system has already started to generate various information from what we asked it. It's giving you the different counts. It's giving you by unit, by different outage types, and then it's showing forced versus planned. And then, hopefully, yeah, it's doing cause code analysis, right? It's telling you, hey, pulverizers were up top, other things were up top. It's showing you seasonal outage patterns and monthly distribution. Um, you get outage duration analysis. So again, the main point we want to make is that with, some of this work, if we needed to do this, um, it would take, a month for somebody to go ahead and create and program, or even if you have Power BI and you had the data, it would take a long, long time. But using AI, you're able to do this analysis very easily and very quickly. And if you like it, you can operationalize it and expose it to the entire organization. And if you operationalize this, then it is not AI anymore. It becomes software. It's just like you wrote something and you created it. But before you do this, you would also go ahead and, make sure that you review it, test it, and it works. But you can see that you can create solutions within minutes. And, this is generating a lot of what you would need. And if you don't like it, you can chat with the AI and have it improve this. Now, these are just simpler examples, right? But, well, it's actually not that simple. But we have folks that have gone in and done, entire analysis where they're putting in their engineering data, cause code data, they're putting in the GADS data, they're bringing in data for Maximo, all these other systems. And we've had one client that's been doing this, and they've been working on it for 18 months, and they've been able to improve their reliability metrics. And it's led to, they're in a capacity market, and just improving some of those has led to over like 2.3 million improvement in just capacity. So there, it looks like smaller improvements, but you're improving EAF, E40 in small batches. But
Are you sharing something or no?
no, no, I'm not sharing. I
Okay.
can see
Sure.
yours, Robert, so that's fine. So yeah, Rashid, if you want to show a couple of other examples, maybe do like, let's just show where we did EAF forecasting or
For the
solar
solar metrics, we can do the
analysis.
solar metrics also, right?
Sure, sure. So,
So
um,
I can show this chat over here, right? So it's like one of the things we did was that NERC provides the solar performance data, or you are submitting your solar performance data to NERC. And what we did was that we got the knowledge, so we kind of got we got the NERC data, or the client provided the data which they're submitting out through our
so
system.
yes, so essentially for the knowledge, we took the NERC DRI, we copied and pasted it into here, right? Whatever the metrics we wanted. And then uh, we took the output file that we sent to NERC and we said, hey, go ahead and create these metrics. And it went ahead and not only does it create the metrics, but then it can visualize this for you. Um, and the reason to do this, right? It's fine. Maybe you can do this, and even our system, right? We'll go ahead and calculate the metrics. But then what you can do with this or fossil, right? You can say, hey, if I didn't have these specific types of outages, what would it look like? Or if I add, if something changes and my outage rate increases by 5% or 10%. So with AI, you're able to do a lot of this what if analysis that you're not able to. And for reliability planning and other purposes, it's huge to be able to do this properly and accurately, right? Because if you wanted to create a system to do this, even for us, it's a lot of time and effort. But using AI, this type of work is very, very easy to do. Um,
So I think at the end, I think we were, again, from once you have an AI, you can create an operational dashboard with click of a button. And here we have some, like the same thing we were discussing was the solar metrics. So once you have that, AI kind of gave you the analysis, and then when you run these operational dashboards, these are not using AI. It's using the code which was generated by AI. So you can have so your end user. So we have a client which is using. So their analysts are creating these dashboards, and maybe almost every few days, and they have about 50 users, different plans coming in and looking at these dashboards. What would have taken them
Sure.
weeks or months, now they're able to do in a
So,
very short period of time.
yeah, sorry, Rashed. And again, this is going live. Each time it's run, this is going live to get the data. And I know there's a reliability where we're having folks that are using it for, settlements to make sure their settlements are accurate. We're having folks use this for forecasting data where they just give the system the forecasting data and it looks at the actuals and it does forecasting as well. So Adam, go ahead. Any questions you wanted
Yeah.
us to answer? I'm sorry.
Yeah, so there's a question from Maxwell Cope, and then after this question, we'll move into the next panel, which Amit is also on. So other questions can be directed at Amit during the panel. Max said he may have missed some of the details on the tool. Is it a model that is housed internally, or is it communicating to an external model via API? If external, what company data is being transferred?
Sure. So this uses something called AWS Bedrock, which is very secure. We are not training the system. The way we work is that and we don't share any of your data. This sends either metadata to AWS Bedrock, which itself does not share anything, or it will send 3 or 4 sample rows. The way the system works is that these models are now smart enough to process whatever is needed. Training gets very expensive, and no company wants to use their data for training. So in these cases, we provided knowledge. Like here, we gave it the NERC DRI, and we gave it the underlying data. And it is actually able to 100% accurately do the work. And if it doesn't, you can test it out. You can tell it, review it, and it will be able to fix it. Um,
So I
so
mean,
yeah, go.
one other thing though, I mean, if a client really wants that they won't be using a model on the cloud, we can also host it with internal models. There are some internal models which can be hosted within the client. So I mean that it will do the job, but if the higher models can give you better analysis. But yes, we have seen some good results also using internal models if you wish to do that. But as Amit said, that we are using air
Yeah,
gaps.
no training and no sharing of data with other systems. So we ask the AI that this is the problem, this is the information, and we ask it, how are you going to write the code to solve it? And internally, we write the code, we access the data. None of the data is accessed. Because what happens if you have hundreds of millions of rows, it's impossible and it's going to cost you crazy amounts of money. So what Rasha did, for example, may have cost 25 cents. If you do this and you're sending millions of rows, it's going to cost you, thousands of dollars just to do some small things. So